Hi everyone, welcome to Maths World. In today's class we are going to discuss about class 8's chapter 1 rational numbers. So in this before going to learn rational numbers we are going to learn number systems. So first one is natural numbers. So tell me, what are natural numbers? Natural numbers are counting numbers are called natural numbers. Okay, so if we want to count the any items or things, we will use these numbers, that is number system. Generally we use the natural numbers in day to day. Okay, so natural numbers are denoted by capital N equal to 1 2 3 4 5 and so on infinity. These numbers are called natural numbers. So smallest natural number is 1. Can you tell me which is the biggest natural number? So we can't tell which is the biggest natural number. So second one is, tell me second one, which is the number system? Whole numbers. Okay, so whole numbers. So tell me, what are whole numbers? So natural numbers including 0 are called whole numbers, that is starting from 0 1 2 3 4 5 and so on infinity. These numbers are called whole numbers. Whole numbers are denoted by capital W. So capital W is equal to 0 1 2 3 4 5 and so on infinity. So these numbers are called whole numbers. Next number system is third one. So third one is what is the number system? Third one, natural numbers, whole numbers, and then integers. Okay, integers. About integers we already discussed it in 7th class deep. Okay, natural numbers are denoted by capital Z. So positive numbers, negative numbers, 0. These numbers are called integers, that is positives, negatives and 0. These numbers are called integers, that is we can write it as Z is equal to minus infinite, minus 2, minus 1, 0, 1, 2, 3 and so on plus infinite. So these number systems are called integer system. Okay, and then coming to fourth one is rational numbers. Okay, we came to our topic, rational numbers. So what are rational numbers? What are rational numbers? Natural numbers, whole numbers, integers, and then also fractional numbers. These numbers are called rational numbers. Okay, so if we take P comma Q are what? P comma Q are integers. P comma Q are integers. P by Q, where Q not is equal to 0. So these type of numbers are called rational numbers. Okay, so we can't forget Q not equal to 0. These numbers are called rational numbers. Okay, so rational numbers are denoted by capital Q. We can write it as capital Q equal to P by Q, where Q not equal to 0, where P comma Q are integers, that is P comma Q belongs to Z. So we can write it rational numbers as like this. Okay, next so now tell me, 0 is a rational number or not? Yes, it is a rational number. We can write it 0 as 0 by 1. So it is like P by Q. Okay, so 0 is a rational number. Okay, and if we write it minus 3, is it a rational number? Yes, it is rational number. We can write it as minus 3 by 1. So this is belongs to Q. Okay, so 13, this is rational number or not? Yes, it is rational number. It belongs to Q. So we can write it as 13 by 1. Okay, so if we take 2 by 3, so tell me, this is rational number or not? Yes, it is rational number. This is in P by Q form. So this is a rational number. If we write minus 4 by 6, tell me, this is rational number or not? minus 14 by 6, you can take any number. So this is in the form of P by Q. So we can say that minus 14 by 6 is a rational number. That is individual numbers and fractional numbers and negative numbers, positive numbers. These whole numbers are called rational number system. Okay. So now we are going to learn about rational numbers. One more number system is there, irrational number system. Irrational numbers. Irrational numbers. Irrational numbers. So these numbers are denoted by Q dash. So under root A form numbers are called irrational numbers, where A is not a perfect square. A is not a perfect square. A is not a perfect square. That is root 2, root 3, root 5, root 8. Like these numbers are called irrational numbers. We can't write it as P by Q. We can't write it as P by Q form. Okay, these numbers are called irrational numbers. These all numbers, that is these whole numbers, that is natural numbers, whole numbers, okay, integers, rational numbers, irrational numbers. These all numbers are called real number system. These all number systems are called real number system. Okay, so R, capital R, real number system, we can denote it by capital R. So this is the introduction about the number system. Introduction about number system. We are going to learn properties of rational numbers at first. Okay, so properties of rational numbers. Sorry. So properties of rational numbers we are going to discuss now. So what is the first property? Tell me. So in 7th class and 6th class we have discussed all the properties. In 6th class we discussed about properties of whole numbers. In 7th class we discussed about properties of integers. In 8th class we are going to discuss about properties of rational numbers. Okay. So first property is, tell me what is the first property? Closure property. First property is closure property. So first property is closure property. Each and every property we are going to discuss about under addition, under subtraction, under multiplication and under division. So closure property we are going to check in rational numbers. If we take a comma b belongs to q, a comma b belongs to q, I am going to check a plus b. If a plus b also belongs to q, then we can generalize that closure property under rational number is possible in addition system. Okay, so each and every property we are going to check under addition, under subtraction, under multiplication, under division. So I am going to check now closure property under addition. So if we take a comma b belongs to q, so a plus b also belongs to q. So if the given system, that is rational number system, satisfies this condition, then we can generalize. Okay, so for example, if we take any two rational numbers, so we already checked in whole numbers, in integers closure property. So whole numbers and natural numbers also rational numbers. So going to check fractional numbers, that is if we take a is equal to 2 by 3, b equal to 1 by 2, so you can take any fractions. So if we check a plus b equal to 2 by 3 plus 1 by 2, so these fractions are improper fractions. I am going to convert these improper fractions to proper fractions. For these I am going to multiply first fraction with second fraction denominator and second fraction with first fraction denominator. So by calculating 2 2s are 4 by 3 2s are 6 plus 1 3s are 3 by 2 3s are 6. So now the given fractions are converted to like fractions. I am going to add directly 4 plus 3, 7 by 6. So this 7 by 6 belongs to Q. So by this we can generalize that closure property under addition is possible in rational number system. Okay. Now we are going to check closure property under subtraction, rational number system. So in this subtraction also, if a comma b belongs to Q, we are taking a, b or rational numbers for example. So a, b belongs to Q. If we check a minus b belongs to Q or not, we are going to check. If a minus b belongs to Q, then we can generalize that closure property under subtraction is possible in rational number system. So as usual, I am going to take a equal to 1 by 7, b equal to 2 by 3. So I am going to check a minus b, 1 by 7 minus 2 by 3. So these fractions are improper fractions, we can't add directly. So at first we are going to convert these improper fractions to proper fractions. 1 by 7 into 3 by 3, I am going to multiply first fraction with second fraction denominator, second fraction with first fraction denominator. 1 3 is 3 by 7 3 is 21 minus 2 7 is 14 by 3 7 is 21. So 3 minus 14 I am going to do directly. Why? Because these fractions are converted to proper fractions. So 3 minus 14 means minus 11 by 21. This fraction also belongs to Q. By this we can generalize that closure property under subtraction is possible in rational number system. Okay. Now we are going to check closure property under multiplication. Closure property under multiplication. So if a comma b belongs to Q, a, b are rational numbers. If a comma b belongs to Q, then a into b also belongs to Q or not, we are going to check. If a into b belongs to Q, then we can generalize that closure property under multiplication is possible in rational number system. So for example, if we take a is equal to 2 by 5, b is equal to minus 1 by 3 or minus 1 by 8, you can take any number. I am going to take small fractions for the simple calculation. So if we do a into b, so 2 by 5 into 1 minus 1 by 3, so plus into minus, minus 2 fractions multiplication. So 2 1 is 2 by 5 3 is 15. This is also belongs to Q. By this we can generalize that closure property under multiplication is possible in rational number system. Next we are going to do closure property under division. Closure property under division. If a comma b belongs to Q, a division b also belongs to Q. A division b also belongs to Q or not, we are going to check. So if we take a equal to 1 by 7, b equal to 4 by 3. So if we check a division b equal to, so 1 by 7 division 4 by 3. So fractions division means first fraction remains same, sign division converting to multiplication. I am going to take second fraction reciprocal 3 by 4. So 1 3 is 3 by 7 4 is 28. This is also belongs to Q. By this we can generalize that closure property under division is possible in rational number system. So by this we completed the closure property under addition, under subtraction, under multiplication and division. So by this closure property under addition is possible in rational number system, under subtraction is possible in rational number system, under multiplication is possible in rational number system, under division is possible in rational number system, we can generalize. Okay, so this is about closure property. In the next class we are going to discuss the remaining properties of rational numbers. So I think you understood. Well, if you think this is a useful video for you and your children, please like, share and subscribe our channel. Thank you. Thanks for watching. Bye.